Hello and welcome you all for this video presentation on the topic data preprocessing and transformation. So here we will be exploring the approach called as normalization and standardization for data analytics. Myself, Dr. Kondekar from Walchand Institute of Technology, Solapur. So these are the learning outcomes for this session. So student will be able to understand what is the necessity of going for these data transformations, and given different data transformation approach, student will be able to recommend which method to be used based on the application for which the data is to be used and the type of data available. So let us try to understand the need of these data transformations, like why we need this normalization, why we need this standardization. So for that, just take an example that you have a data about three different instances, three different friends in your contact. So Bernhard, Juanith and James. So these are the three friends. Now what you want to have is you want to come up with the conclusion, or you want to calculate the similarity conclusion about the which two friends are more similar. So that is the problem, you take it as a problem. So three friends are there, out of three which two are similar. Now you know that the similarity can be measured in terms of distance. In case of this machine learning and data analytics, we can have some distance matrix used to check the similarity, and here higher the distance, lesser will be the similarity, lower the distance, higher will be the similarity. So if you take two friends and you calculate the distance, if you find that distance is lower, means they are more similar. Now we have two quantitative attributes, one is age of the friend and second is the education level of the friend. So education may be that 10th, HSC, SSC, the graduation, post graduation, doctoral levels, and those are converted into quantitative values and they are numbered, let us say. So you have a friend called as Bernhard with the age of 43 with the education level 2, Juanith age 38, education level 4.2, and James age 42 and education level 4.1. Now I want to find out which of these three friends, out of these three friends, which two are more similar. And then what I do is I use this formula, or I use this approach called as calculating the Euclidean distance. Now look at the problem, where exactly is the problem, why we need this normalization is, what I do is I calculate the distance between, let us say, Bernhard and Juanith. Euclidean distance, the formula will be maybe under root of this 43 minus 38, difference you calculate, you square it, 2.0 minus 4.2, whatever difference you get, you square it, you sum those square differences and you take square root of that. So we call it as root mean square values. Okay. So what is done is this Euclidean, not root mean square, it is Euclidean distance between these two attributes, means you calculate the square differences, you add it and you take square root of that, right? So now I calculate the Euclidean distance. So this is what distance I get. So what is the conclusion from this? The conclusion may be the distance, where you find the distance lesser, 2.33 is the lesser value. So this is the least distance. So least distance means more similarity. So the conclusion may be the Bernhard and James are similar. Okay. Now only one change I am doing is, what is done is, instead of representing the age in years as it is, what is done is age is represented, let us say, in decades. Decade in the sense 43 age in years represents 4.3 decades. 38 age represents 3.8 and 42 represents 4.2. So if I have these values represented in decades, again I calculate the Euclidean distance between each of these pair possible and I come up with these Euclidean distance value. And which is the minimum value? Minimum is 0.41. And what is the conclusion? The Zenith and Gems are more similar. See, look at the problem. You have the data, same data. Only age in years consider, you come up with a different conclusion. Age is considered in terms of decades, you come up with a different conclusion. And this is not expected. So, what is to be done is, or what is expected is, your result should be independent of the data values. How you consider those data values. And you know that many times when you are analyzing multiple attributes, when you are doing multivariate analysis, the different attributes may take different ranges. You know what is range of the attribute? It's difference between minimum and maximum value. So if they have different ranges and those attributes I am using to calculate the distance, then the attribute which is having higher range will have more impact on calculating the distance. So what can be done in that case? So I want some solution where the attribute may take different values in different range, but when I am making the calculation, all attribute values should have the same range. And this is something interestingly can be done by the approaches like normalization and standardization. Hope you understand what is the need of this normalization and standardization. Once you understand this need, you will understand the solution given here. So let us have this solution, how you can have the normalization. So there is one simple approach called as min-max scaling approach. Min-max scaling. So let us say whatever data range you have, what I want to do is I want to transform that attribute range maybe from 0 to 1 or -1 to 1, or there may be some other ranges, but these are quite popular and widely used ranges. So that's why I am considering this. So data is having different range, like let us say age. Here you have age is means it's a 2-digit number, right? So and then if you look at the education, so it's a single digit, and if you look at the range of the age and range of the education is different. Now what I can do is I can apply this normalization on it. So normalization done with the approach called as min-max scaling is discussed here. So this is the formula for doing the normalization. This x dash represents the normalized value of the attribute. Let us say you have this age and this 43 value you want to rescale. Okay, so you want to have a scaling of the age as in between 0 to 1. So what can be done is this x will be 43 minus x mean. What is the minimum value of the age? Minimum value of the age is 38. So what will be the difference? 5 divided by x max minus x mean. So again that difference will be 5. So 5 divided by 5 is 1. So that's why the rescale age is 1. Okay. So 38 so is represented as 0. That is the interpretation of min max scaling. So minimum value will be represented as 0 and maximum value is represented as 1. Okay, if you are considering this 0 to 1 as the range. So like that you can have the rescale values of the education, and then again this education is rescale between 0 to 1, and then you can come up with this calculations of the distance between these attributes. Another approach of this normalization is normalization by standardization approach. Okay, so this is a standardization approach instead of a min-max scaling approach. So if you use this standardization, so what happens is whatever is the range, okay, so that range gets converted into the data in such a way that the data is centered around 0, and then you get standard deviation of 1 in that data if you use this approach called as standardization. Now how exactly the standardization can be done? So again this is the formula for standardization. So this x dash represent the standardized value of the attribute x. Okay, so what you consider is, let us say this 43 I want to represent as the standardized age. So what is to be done? This will be 43 minus average of the age. This x bar represents the mean value, average value. Okay, and divide it by the standard deviation value of the age. Okay, so later with one example also we will discuss that, and then if you do these calculations, so this standardized age value is coming out to be 0.76. So like this, all these values are rescaled and then are standardized by using this formula, and this approach is called as standardization approach, or this approach is also called as z-score normalization. So this is the example where exactly these calculations are done. So how this standardized value is calculated? So average value of the age is, all these age values are summed divided by 3. So I am getting average value x bar as 41.0. Okay. Average value of the education can be also calculated. So education levels we have in the original data set as 2.0, 4.2 and 4.0. So average is coming out to be 3.4. So this part is been calculated, and now you need to have the calculations of the standard deviation. So this standard deviation is also calculated for both the attributes, for the age as well as education. So for age the standard deviation is coming out to be 2.64, and for education it is 1.21. So this is the formula for standard deviation. Is quite similar like root mean square value. So it is a root of mean of square differences between the actual value taken by the attribute and its corresponding mean. So these are the standardized these are the standard deviation values, and then once you have the standard deviation values, you can do these calculations like this. The standardized values of the age for Benhard, Dwenith and James, same is done for the Benhard, Dwenith and James for their education levels, and these are the values you are getting. And then this is the summary table where you have data, and then what you do is, now you do the normalization with this min max scaling, and these are the normalized value of the age and education by min max scaling, and these are the normalized values by using the standardization approach for the age and education levels. And then with these values means once you have these normalized values, okay, so Euclidean distance if you calculate with the normalized values, so you come to this conclusion. So this distance is lesser. So this Dwenith and James are similar kind of friends, and this is how you can avoid the problem of data with different scales. So this is all about the presentation. These are the various references used for this video presentation. Thank you.